The study of the metropolitan context through the semantic package allows the selection of scalable, efficient processes to represent the metropolitan complexity. The aim of the semantic package is to design consistent procedures to build metropolitan cartography maps, starting from the identification and the use of informative levels linked to an efficient data structure. To produce the metropolitan existing situation analysis, there are two types of maps: syntactic maps and value charts. The syntactic maps analyze, interpret, and design the metropolitan structure of the underlying physical structure made by the intersection between networks of the wet and dry ground. The value charts capture the actual everyday living environment of millions of metropolitan dwellers by describing the urban public-private relationship and the access to public services and resources. Starting from the semantic package, it is necessary to identify a finite number of significant zones of reading. A zone of reading allows one to create own paths to read the dynamics and the metropolitan complexity, and at the same time, it is the tool to detect the informative levels for the metropolitan cartography maps. For example, from this general semantic package, the zone of reading in blue highlights the impact of the urban growth on the green infrastructure that assesses planned restriction on growth regarding natural hazard and preservation of natural and cultural richness. We could name this synthetic map as Preservation of Natural Asset under the Influence of the Urban Activities. The maps drawn with the informative levels driven from the zone of reading are a systematic observation that tracks behavior over space and time. One of the main goals of metropolitan cartography is to avoid thematic mapping. Each zone of reading can be translated in a spatial representation linking the metropolitan keywords and the related concepts with spatial resources connected to the data structure. A data structure is a systematic way of organizing and accessing data. For example, urban growth can be related to a dataset that represents the evolution of building footprint and location of urban functions in space and time. Scale is one of the most important criteria when choosing a spatial resource connected to informative level in a zone of reading. The same informative level refers to various resources depending on the scale of representation. For example, at the extra-large scale, green infrastructure is a network of areas covered by vegetation. At the large scale, it is represented by a specific classification of the vegetation, by season, density, height of the trees, loss or gain of vegetation in time, the relation of topography and the distribution of vegetation, the effects on air quality, and so on. At the medium and small scale, it is possible to classify tree species, monitor the occurrences of wildlife species, localize the space for recreation, and so on. From the general semantic package, identify the relevant zones of reading to describe the metropolitan context. Every zone of reading is a tool to extract the informative layers for a metropolitan cartography map. Name each map. Is that map a synthetic map or a value chart? Select the informative levels connected to the metropolitan keywords and related concepts for each metropolitan cartography map.